Hello and welcome to this lecture. In this lecture you are going to learn what image segmentation is, which different kinds of image segmentations are available, and also what we are going to develop in this course. So let's get started. At first, let's take a look at some similar tasks. Because if you have some experience in image processing with deep learning, you know about the classical tasks of image classification. That is basically the most simple approach. If you have a certain image and you have a trained algorithm, this image classification model would be able to tell you, okay, in this image you can see a banana. So there is a class label provided for the complete image. The next level of complexity is object detection. This kind of techniques are available and can help you to not just get a label for the complete image, but also for the region of the banana in this image. So where image classification can tell you what is shown on an image, object detection can tell you what and where something is on an image. And then it's putting some bounding box around it. So this is what you can see here with the red rectangle. So now we want to go one step further, because the next level of complexity is to not just create bounding boxes, but to actually predict individual pixels on an image. So this is what image segmentation is about. You get predictions of classes for each pixel, rather than for a complete image or just for a certain region of an image. And this kind of technique, besides that it's super cool, is really having some business impact. So we can use it for many different fields. For example, for medical imaging, for satellite image processing, or for autonomous driving. And here you can see some example. You have some ground truth image at the left-hand side, and then an example of semantic segmentation, where you can see different objects in the image. So you can see that you have different colors for the street, for the pedestrian walk, for the cars, the persons, and so on. And you get these different classes predicted for each pixel of this image. Before we go into different kinds of image segmentation, I want to show you just on a high level what the mathematical representation of this technique is. And actually it's not too complicated. Imagine you have some input image, which is shown here at the left-hand side. And the segmented version of this would be just having integer values for the different kinds of classes, for the same number of pixels for the height and width, and then each class is corresponding to a certain number, so each pixel gets a number assigned to it. So that's basically it. We have our ground truth image with the dimensions height times width times 3 for a color image, or if we're working with grayscale, then we just have one color channel. And we have a corresponding segmentation mask, which is having the same number of horizontal and vertical pixels, and one channel corresponding to the mask values. You could also imagine it like this. So instead of having just one mask, you could also have several masks. So the dimension would be now height times width times 5, because we have 5 different classes here. And then each class matrix is basically binary, so we have zeros where this type of class is not visible, and we have the corresponding number for the pixels on which we can see these different classes. Alright, so by now we know the high level of this, but there are actually more techniques in the field of image segmentation. We have semantic segmentation, instance segmentation, and panoptic segmentation. And here I just want to tell you what the differences are. So again, imagine that you have some ground truth image that you can see here. If we're working with semantic segmentation, then you can see the corresponding result here. We have the different objects, like the different cars in a certain color, and the street and the persons, but actually you cannot differentiate any of these cars. So basically all the cars are overlapping and they are considered to be just of the class car. Similar for the persons, so there are many different instances of persons which you cannot differentiate you just get the prediction on this class, which is person. And to overcome this, because in certain cases it's important to not just be able to predict stuff, but also to predict individual things. And for this we have instance segmentation. And here you can see the same image. And now with instance segmentation, you can see there are actually different colors for the different cars. So it's not just predicting each of these cars, and then we have overlapping pixels of all these different objects. Actually now we have many different colors corresponding to the conclusion that the algorithm is able to predict the individual instances of these classes. And similar for the persons. And then we have the last type of technique in this field, which is panoptic segmentation, which is bringing in the best of both worlds. Here each pixel gets a label, and with this individual objects are predicted and also separated, as well as that you can see general stuff in this image. So these are the three different kinds of techniques in the field of image segmentation. And now I'm going to show you what we are going to develop in this course. We are going to work with a dataset on satellite images, and these satellite images are consisting of 6 different classes. So on these images you can see buildings, land, roads, vegetations, water, and then there's a residual class called unlabeled. So for example, we have some input image like this, and we have some true mask which is provided. So here you can see then with the different colors, the different types of objects. And we are using these 2 different inputs, the input images and the true masks, to train a neural network. So we are training our own semantic segmentation network, so that in the end we are able to take a new image and we apply our trained algorithm, our trained model, and we get as a result our predicted mask. And to me, this is one of the most impressive techniques in the field of deep learning. And it's really fun to implement this and to find out how all this works. Thank you, and see you in the next lecture.